I will summarize these techniques, how they can use in real-life technology in sectors.
So the concept of HCI was introduced in early 1980s, making the interaction between humans and machines massively easier and more efficient. And there are many examples out there of HCIs, like mice, keyboards, different cameras, and etc. Here we can see how mouse has improved until an optical mouse was invented, which I will be talking about. So this is the optical mouse. To detect the movement, an optical mouse uses a light source, which is LED, a photodetector here, as you can see here, it's a LED, a photodetector, typically a CMOS, and a digital signal processor, DSP. So first, the light source produces light that shines onto the surface. Then the light is reflected back and picked up by the CMOS sensor, forming an image of the local surface. How this movement is translated? Well, photodetector captures the image of the surface, sends it to DSP. DSP detects how image patterns have moved, then processing, then determines how far and fast the mouse has moved. Then send the data to digital data, of course, to computer to update the cursor location on the screen. But now you might be asking yourself, how can we see a very smooth movement? Well, this process happens hundreds of times per second. And here you can see detection of movement by correlating two images. So here we can see a block diagram. It consists of an array of photodiode, this block, for detecting a light pattern image, a storage for the image, and a correlator to compute the correlation between the stored image and a current one, and a decision circuitry to determine the direction of motion, and a self-timed controller to sequence the entire system. Let's dive into photodiode array. So simply, the sensor here is a photodiode. As you can see here on the left, it's a single photodiode, but here photodiodes array, as you can see here, is used, and you can think of it as a matrix of photodiodes. So how a photodiode works? Well, a photodiode is a special form of PN junction diode that produces current when the junction is exposed to light. It works in reverse biased condition. So when the photodiode is not exposed to light, then only minority current will flow through it. This current is dark current, which is very small. Then as the junction is exposed to light, the temperature goes up. This increasing in temperature causes the current to flow, which means flow of current. Here you can see the IV characteristics of photodiode, and you can see as intensity of light increases, the current increases as well, and it will totally become independent of applied reverse voltage. So let's see how one pixel imaging happens. First, pre-charge signal comes from self-timed controller, letting the capacitor to be fully charged. Then diode discharges the capacitor at a particular rate depending on the light intensity. Then here is the magic. This charging pattern gives the properties of this pixel. Then photodiode is sampled and stored at once. And lastly, capacitor is fully uncharged, and the cycle keeps moving like that. Here is the circuit, and thus for imaging, an array of these photodiodes start out with all diodes charged and discharged. And this charging process depends on the intensity of each photodiode. Let's see what's inside the decision block here. So these three inputs are from correlator circuitry. One of them will rise high enough to begin pulling down the other two. This is the idea. So the final state of the circuit will be two lines low and one line high, indicating which direction the image has moved or not moved. Here is our PSpice simulation of the circuit, proving that it's enough to feed the circuit with a single logic 1 input to force the other two outputs to be logically 0, as you can clearly see here. And now I will leave you with my friend Hakkı to continue.
Now we will go through a Hci example with the support of computer vision, and we will design it together with you. We want to design, let's say we want to design a 3D working environment which is interactive, and we can create our avatars from our images and we can use them in this process. So let's use a VR asset, which includes some cameras and lots of other sensors. But today we will focus on mainly cameras due to vision part. So which properties we can use? Let's say we want to map our room in 3D without a special equipment. Maybe we want a depth map, and we want to understand what happens inside of that depth. By the way, saying a depth map is not enough. Depth map is a special picture that defines the distances of objects from a camera. For example, in this picture, helicopter is closer to us. That's why it's white. And sky is far. That's why it's black. And this depth map shows just the pixel distance. But we have to group them to detect objects. And if we can detect them, we can get marvelous results. So we know our problem. We solve some tricks to solve that. And let's see how people solved it in real life. Our first candidate is stereo camera. In stereo cameras, we will get at least 2 images with different perspectives. And if we find 2 matching points in 2 images, we can calculate their distances by triangulating. So what triangulation? We have to create a triangle, right? Here we can see their positions are different in 2 cameras. And as long as we can detect them in both of pictures, we can find where we have to go. And here we can see the calculation steps. We know the distance between cameras, and we know the distance between lens and the visualizer sensor in both pictures. And we know the coordinates of them in both pictures. So we can calculate the distance and the coordinates of that object in 3D space. It becomes a simple high school math class. Then, as I mentioned before, we have to segmentate them to create different depth layers. Here we can see it is a bit noisy, but at least we can see these objects and how far they are. Of course, it is open to improvements. That's why people didn't stop and started working on AI. AI is too wide topic, and that's why we will just focus on mapping a human in 3D space. To train an AI, what we need lots of data, and these data should be labeled. And of course, we need an AI model. Then we have to train it, test it, modify it, and do it iteratively. And the best thing about this, thanks to internet and cloud computing, now we just need a camera with Wi-Fi connection. We do the rest of the complicated stuff on cloud. By the way, labeled data, what we want from a labeled data? Labeled data, for example, this is a frame from a data. There are humans, and we want some information about humans. Where are they? What are they doing? And what is the movement of their body part? Or maybe we can segmentate their part. And this is how a model works. We give an input, a black box, which we will go through next slide. And we want specific input. And since we give model, we want this labels from this image, this task becomes a supervised learning because we give them a label. And at the beginning, model will give you a noise or a blank out, but through a process which we call learning or backpropagation, model starts to learn from its mistake by error decreasing gradient function. And this is our model. We will use convolutional neural networks to extract information from 2D picture. And we interpret those features by using the convolutional layer. And we can even call it decoder. And we create a 3D map of a human. And these are our results, which are marvels. We have 2D, we don't see the back part of humans, but now we can see them. And as at the beginning, I mentioned that we want to create our avatars in 3D. Thanks to this AI, we can do it now. And since we know where is our body parts and their motions, and we know that in 3D space, we can interact with 3D space by just clicking them with our bare hands. And that's my part. Thank you. Emin will continue.
Thank you, Hakkı. In my part, I split HCI into 2 parts, direct and indirect HCI. I will explain one by one. I will tell you some startups research. I will explain how to work, and I spend my time on mathematical approach. Direct HCI is not that interesting. Ahmed already explained the process. It based on your abilities and style, and you can see the 2 startups. I will explain them, and also you can see the researchers and laboratory workers about direct HCI. You can send an email to them. Let's move on to VC. They use Wi-Fi signals to detect your body, but it's not an interesting part. The really interesting part is they use a Doppler effect to detect your motion with Wi-Fi signals. It's really interesting. If your motion and your reflected signal is in the same direction, the frequency will be higher. Otherwise, it will be lower. It's a high school knowledge. This frequency deviation let us know your motion. And example output is here. Wi-Fi Doppler imaging. You can see we can detect bodies and motions with color. Let's move on to Indirect Hci. This is a little bit dangerous because these informations can be gathered without your knowledge. And ultimate goal of is recognizing human. So how to recognize a human? I will explain keystroke dynamics and mouse dynamics a little bit, and I am putting some funny thoughts here. If you are interested in, you can search on them. You can recognize a human with his or her online game strategy or programming style. You can see the last decade's research here. Let's move on to keystroke. Every person has identical hold and release time for each case. So your computer can recognize you from your keyboard. You don't have to put some password in future, I believe. There is a company called Hci. It analyzes your customer from your website, if your graphical user interface efficient or not, if your customers like your products or not. You can improve yourself via analyzing your behavior with interaction of computer. And if you don't believe that you understand the difference of direct and indirect interaction, you can search and read this article. Let's move on to mathematical approach a little bit. You have to set a parameter, and in general, people use distance of eye. You can see Hakkı's picture here, and distance of eye can be represented like that. We don't use it directly. Instead, we put a weight for it. So if you can't visualize this relation, we can see the characteristic of it. You can write a simple MATLAB code, and here is the Di and Ci characteristic depending on the constant. The constant will be in general between 1 and 3. If you don't want to get these funny results, you have to set these parameters right. And if you're interested in more techniques and software, you can always search on GitHub. I put here most famous 2 repositories. And if we have time, I will explain them to you. You need a faster calculation with lower technology, so you can use matrix form. This is exactly the same formula and logic. The only difference is this is in matrix form. You can use the same procedure for audio recognition. This omega is results of Hakkı software. It's a trained AI. You basically multiply your input to recognize your human or person. You can use both face and audio recognition in the same time to get a better result. You don't have to purchase high quality computer. These are the minimum qualities of computer. You can look at them later. I want to mention about famous products in recent years. Siri is one of the famous products, as I told you. Apple has a machine learning research. You can search them. You can command your iPad and telephone with your voice. You can search on internet, call a friend. It's one of the most famous human-computer interaction. You don't have to use some keyboard or mouse. And Neuralink is the future, we believe that. Ahmed explained many sensors. Hakkı used VR consoles and head. We won't need them because this chip will be replaced your brain, and you can connect internet. You can see 3D environment places, your friend, without any sensors or these devices. We believe this is the future. And lastly, you can see our articles and softwares with this drive link. Here is some suggested videos. This is our references. You can see further explanations at appendix, the results and explanation of GitHub. You can watch this video. If we will have a time, we can watch it together. You can see some comparisons too.